Welcome everyone. Today we're going to talk about density. Density mathematically is a ratio of mass divided by volume. And density is also known to be a derived unit. If you remember, mass is a base unit measured in kilograms, and volume is already a derived unit. So when you combine mass and volume, density is one of the derived units that we talked about. It is also an intensive property. And if you look at the definition of what an intensive property means, it means that it is independent on the quantity of matter. I'll give you an example. It does not matter how much, let's say, water you have. Whether you have a gallon of water, 10 milliliters, or a few drops of water, the density of water is the same regardless of the amount of matter that you have. Now, what I'm going to do here, I'm going to discuss density first conceptually. You'll notice that it says down here that the density of a solid is much greater than that of a liquid, and the density of liquids is greater than that of gases. We'll talk about the exception of ice in just a moment, but I'm going to show you what I mean by this. If you look at the three states of matter, conceptually, the more compact the particles are together, the more dense something is. Check here out the solid. Notice how it's more compact. A solid is going to have a much greater density than the liquid counterpart. Notice in the liquid state that they're not as compact. They're a little bit more spread out. Now, when you look at a gas, you'll notice that gases are very spread out. They're not compact at all. So the more spread out that the particles are, the less dense that the substance is. Now, water is the only oddball that doesn't follow this pattern. You see, when water freezes, instead of becoming compact like a solid, water actually spreads out. It expands. So if you look at water, the state of matter in which the particles are closest together for water would be in the liquid state. And if you can verify this yourself, if you get some ice cubes and you put it in a glass of water, you will notice that the ice cubes float to the top. The water, being more dense, stays at the bottom. Now, you'll also notice here the units. Okay, I'm going to talk about these units with the three states of matter. Solids are measured, since density is mass divided by volume. The mass is going to be measured in grams. In chemistry, we measure masses in much smaller amounts instead of kilograms, divided by cubic centimeters. Now, a lot of people don't know this, but this is important that you realize that a cubic centimeter is equivalent to a milliliter. So when you look at a cubic centimeter equal to a milliliter, you'll notice that for solids, we tend to use the cubic centimeter as the chosen unit of volume. For liquids, we usually use grams per ml. But at the end of the day, a milliliter and a cubic centimeter is the same thing. Now, for gases, since gases are so spread out, and they usually spread out and occupy a larger volume, we usually measure gases in grams per liter. So those were the three that I circled here earlier, and it is very important to realize that a cubic centimeter and a milliliter are equivalent. Okay? Now, let's take a look at one other thing here about density. Density also is dependent on temperature. You see, if I heat an object up, it starts to expand. And the more that something expands, it actually becomes less dense. So heating an object, which involves temperature, will influence the density of a substance. Now, let's talk about something in general. If you look at water, water pretty much is about 1 gram per ml in terms of density. And if you look at the list here, you will see that some substances are more dense than water. You have aluminum at 2.7, you got lead at 11.4. Those are grams per cubic centimeters because they're solids. Then you have other liquids like ethanol at 0.789, charcoal. Notice how ice is less dense than water. And because of this, this is what we were talking about earlier about floating. You see, the density of water we established as 1 gram per ml. So if a substance, okay, like for example over here, lead, which is 11.4. So let's put here lead at 11.4 grams per cubic centimeter. If you put something that has a density greater than 1, it will sink in the presence of water. So if you had a graduated cylinder here and you put the water, you had some water and you threw some lead in here, it will sink to the bottom. Let me use a different color here for this. So if we had a little piece of lead and we put that in the water, it will go all the way to the bottom. So it will sink. Now, the opposite is also true if you have something that's less than 1. We saw here how ethanol is at 0.789. We could just round that to 0.79. Most oils are around 0.79, 0.80, 0.81. That's why perhaps when you've seen oil and water together, you've seen that the oil will float. Anything that has a density that is less than 1 will float. So if you had water here, we'll go back to the original color. So if we have some water here and we put some oil, let's use a different color for the oil will float on the top, and oil and water don't mix, so you'll actually see 2 layers. The water will be at the bottom because it's more dense, and the oil will be at the top. So this is conceptually how density works. Now, let's take a look at mathematically. See, density's original formula is that density is mass divided by volume. It's a ratio of mass to volume. So you may be asked to find density and you'll be given the mass and the volume. Usually you're going to need to convert the mass to grams and the volume to milliliters or cubic centimeters, which is the same thing. Now, not always are you solving for density. Perhaps maybe you're solving for mass. If you look at the third equation on this page here, you'll notice that if you multiply density and volume, which is this equation down here, if you multiply the two, here's volume and density, you solve for mass. Okay, so that's another possibility. A third possibility is maybe you're looking for volume. So if you were to get this equation here and solve for V, for volume, you'll notice you'll get this second equation. Volume will be the result of getting the mass of the object divided by density. So not every mathematical problem that you have will involve the original calculation, density is equal to mass per volume. You may be asked to find volume and you may be asked to find mass. So it is important that you know the original equation and how to algebraically rearrange it so that you can solve for volume or for mass. We'll take a look at mathematical problems involving density in our next video. Okay?